Hello everyone, my name is Akanksha Zadav and I am here to give you a presentation on Unit 1 Basic Concept, which is our ISE 1 activity under the guidance of Mr. Sabishwaran sir. So let's start with the content of our presentation. The purpose of this presentation is give you a basic idea about our solar system. In my presentation, I will focus on content. First, I will begin with the solar system. Then I will move on the reference frame and coordinate system. After that, I will looking at celestial sphere. Then we will see the equinox, then motion of vernal equinox, and also Kepler's law, Newton's law, and so on. Now we will see the solar system. The story of solar system is our solar system consists of stars, the sun, and everything bounded in the gravity. The planets, which are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Beyond our solar system, there are more planets than stars in the night sky. So far, we have discovered thousands of planetary systems orbiting other stars in the Milky Way, with more planets being found. Most of the hundred of billions of stars in our galaxy are thought to have planets in their own, and Milky Way is one of the 100 billion galaxies in the universe. Uh, there are there are many planets systems like our in the universe, which consisting the planets objects in between them. Our planetary system is called the solar system because we use the word solar to describe things related to our star, and after that the Latin word for sun is solis. So we called our solar system as solar. The solar system is defined as gravitationally bounded system of sun, and it consists moon, asteroid, comets, meteoroids, and interplanetary gas, dust, and all space in between them. The planet, our solar system consists of stars, sun, and everything bounded to its gravity. The planets Mercury, Venus, Earth are moving around the sun, as we can see in the picture. And our solar system is made up of stars, 8 planets, and countless smaller bodies such as comets, asteroids, and meteoroids. After solar system, we will move forward to the reference frame and coordinate system. So, what is reference frame and coordinate system? A coordinate system establishes the orientation of an observer object or field in space, and reference frame is establish its motion. So in reference frame and coordinate system, we will see the celestial sphere. In that we will see celestial equator, then celestial meridian. After that we will see obliquity, then equinox, vernal equinox and autumnal equinox. Then we will see geocentric rotating reference frame, and after that geocentric non-rotating reference frame. It contains vernal equinox. First, we will see about celestial sphere. Celestial sphere is the imaginary sphere that surrounds the earth. It's called celestial sphere, and it's a useful tool to reference real and imaginary point on the sky. The celestial sphere was a way of explaining the visible universe in ancient times. Although we now understand the universe differently, the idea of celestial sphere is still used because it offers a simple way to think about the stars. That is helpful for navigation. The another definition of celestial sphere is it is a fictitious sphere centered on the earth upon which all celestial bodies can be projected. Celestial poles are defined as the points where the Earth's rotation axis intersects the celestial sphere. Uh, it intersection of Earth's equatorial plane with celestial sphere in celestial equator. In celestial sphere, there are many terms like celestial equator, then celestial pole, Earth's north pole. Uh, if we go to the deep of celestial sphere, we will learn about this concept. But for our syllabus or our point of view to study, the celestial sphere is just the fictitious sphere centered on the Earth upon which these can be projected. That's it. Now we will move towards ecliptic. The ecliptic is the orbital plane of Earth around the Sun. From the perspective of an observer on the Earth, the Sun's movement around the celestial sphere over the course of a year traces out a path along the ecliptic against the backward of the star. The ecliptic is an important reference plane, and it's the basic of coordinate system. If Sun is observed from Earth, it possesses a motion. The Sun moves eastward along the start rate of 1% per day. As we can see in that the path of the Sun over the celestial sphere is called ecliptic. It's this red line is ecliptic, the path over the Sun. You can see the path over the Sun. This is the Sun, and the path over the Sun is called as ecliptic. Now we will see obliquity. Related to the planet's plane of orbit. As an orbiting plane, as an orbiting planet spins on its axis, obliquity is an angle between a perpendicular to its orbital plane and spin axis, the tilt of its axis. We can see here, this is obliquity. Ecliptic plane is inclined to the equatorial plane at an angle referred to as obliquity of the ecliptic. We can see the obliquity angle 23.4. This is obliquity. Now, equinox. An equinox is an event in which a planet's subsolar point passes through the equator. The equinoxes are only time when both northern and southern hemisphere experience roughly equal amount of daytime and nighttime. Equinox cases are happening twice in year, for 21 March and 23rd September. And equinox is an event in which planet's subsolar point passes through its equator. We can see in the picture the intersecting line of the equatorial plane and the ecliptic plane is known as equinox line. When for an observer on Earth, the sun crosses this line, day and night have equal length, and these crossing points are called vernal equinox and autumnal equinox. We can see here it is autumnal equinox, and when these points crosses, its autumnal equinox is opposite to this. No, its vernal equinox is opposite to this. Vernal equinox occurs in March, and autumnal equinox is occurs in September. Now, geocentric reference frame. ECI, which is Earth-centered inertial coordinate frame, have their origin at the center of mass of Earth. Here, here, and it is fixed with these stars. Now we will see motion of vernal equinox. Vernal equinox occurs when the tilt of Earth rotational axis reaches a particular position. We all are aware of the imaginary axle. The Earth spins around once every 24 hours. We all know that Earth around herself for 24 hours. While we might imagine that axle to be vertical, that's perpendicular to Earth's orbit plane, the axial is tilted about to 23.5 degrees from vertical. So vernal equinox occurs when the tilt of the Earth's rotational axis reaches at a particular position at 23.5. Here we can see. It's 23.5. Vernal equinox is two moment in the year when the sun is exactly above the equator and day and night are equal length. Also, either of 2 points in the sky where ecliptic and celestial equator intersects. Now, next we will move to the Earth atmosphere. Most of planets in our solar system have two or three constituents that makes up most of the atmosphere. For example, Venus and Mars have 98% of their atmosphere in carbon dioxide and nitrogen, while Earth has 99% of its atmosphere in nitrogen and oxygen. So the atmosphere of Earth protects life on Earth by creating pressure allowing for liquid water to exist on the Earth's surface. The atmosphere of Earth is the layer of gases known as collectively as air, retained by Earth's gravity that surrounded the planet and forms its planetary atmosphere. We can see in this picture. This picture contains the atmosphere of Earth, that which part of Earth containing how much amount of the atmosphere of Earth. Now, the atmosphere can be divided into layers based on its temperature, as shown in figure. These layers are troposphere, stratosphere, mesosphere, and the thermosphere. A further region beginning with 500 kilometer, which is called exosphere. We can see in the picture. The picture is showing that the layers of atmosphere at which level. Okay, first one is troposphere. This troposphere is the lowest layer of our atmosphere, starting at ground level. It extends upward to the 10 kilometer, above 33 feet from sea level. Then stratosphere. The next layer up is called stratosphere. The stratosphere extends from top of the troposphere, about 50 kilometer. Third one is the mesosphere. Above the stratosphere, it's the mesosphere. It extends up to a height of 85 kilometer above our planet. And then thermosphere, the layer of very rare air above the mesosphere called troposphere. And the last one is thermosphere. Temperature in the upper thermosphere can range from 500 degrees Celsius to 2000 degrees Celsius or higher. The aurora lights are occur in the thermosphere. Now we will see Newton's law of motion. We all know the Newton's first law of motion, that every body continues in its state of rest or uniform motion in a straight line unless it is compelled to change that state by force immersed upon it. An object is at the rest until it uh, it act- it will be acted by any force. We can see in the picture for better understanding. Uh, Next, we will move to Newton's second law. The rate of change of momentum is proportional to the force immersed and is the same direction as the force. That force is equal to mass into acceleration. And third one, we all know that every action there is equal and opposite reaction. The motion of you can take one example like the motion of lift from an airfoil. The air is deflected downward by airfoil's action, and in reaction the wing is pushed upward. You We can take the example of sailing balls. Then next one is Newton's gravitational law. Any two bodies attract one another with a force proportional to the product of their masses and inversely proportional to the square of distance between them. So G is gravitational constant. Here we have given with the gravitational value. Next, we will see Kepler's three laws describe how the planetary body orbit around the sun. They describe the planet moving elliptical orbit with the sun as a focus. Newton's second law describes a planet covers the same area of the space in the amount of time, no matter when it is in orbit or not. Third law is giving a planet's orbit period, which is proportional to the size of its orbit in semi-major axis. The Kepler's first law, consisting of each planet's orbit about the sun, is an ellipse. The sun's center is always located on the focus of the orbital ellipse. The sun is one focus. The second law is imaginary line joining the planet and the sun swept equal areas of space during equal time of interval as the planet orbits. and th- uh, and third law that period of planet is proportional to the period its law of period that a planet orbit period is proportional to the size of its orbit or its semi-major axis.